To finish out the lesson on linear models and using them to predict or create linear models, I want to talk to you a little bit about correlation and scatter plots. A scatter plot is when we have several ordered pairs that are all graphed on the same coordinate plane that don't make a nice, neat straight line. So as you can see on your screen, there are several different scatter plots. And what we're looking for is we're trying to make sense of scattered data. So looking at this first example here, notice that in general, these tend to move up from left to right in a linear way. So this would be linear where my slope is positive. It's a positive slope. Looking at this scatter plot, they definitely have a pattern and they appear to be going down from left to right. So again, that's linear where m is less than 0. Looking at the other three, there definitely seems to be a pattern, but none of these are linear, meaning they don't make a straight line when they're graphed. Now, if you take statistics, you talk about some of these other models, but right now we're just going to focus on the linear models. So here is some baseball data, and we're going to use this to make a scatter plot. And then we're going to try to use that data to write an equation. So if you look at the graph here to the right, this is all of the data that I had on the table on the last screen. And what I've done is I've drawn in this blue line. So I did this myself. I said, this is about what that data looks like. So in a real life scenario, if you were in a classroom and everybody was doing a scatter plot, everybody's line would look a little bit different because basically I sort of just freehanded this. Obviously I used a computer tool, but if I were doing this by hand, I would have just drawn in a straight line where I thought my data would go. So I'm trying to describe the data. What we're going to do now is we're going to use 2 points from our line. So again, if I were doing this in the classroom, these are the 2 points that I see go on my line. These 2 points right here. But if you were drawing your line, yours might look more like this. And then instead, you would be using the coordinates from this point and the coordinates of this point. So when you're creating a scatter plot, it's important to use 2 points from the line that you drew, not any 2 points on the scatter plot. So if I were to use these 2 points to find the slope, I would use my normal slope formula, y2 minus y1 over x2 minus x1, and we can see the slope I get is 59.55, which of course is rounded. In general, when we round, you round to 2 or 3 decimal places. Next, I'm going to use point slope form, and remember point slope form, I'm going to use the slope that I just found, which is the 59.55. I'm going to choose this point, 32.2, 706, and I'm going to use point slope form. I'm going to distribute and I'm going to find my solution, which is that y or f of x, depending on the format that they're asking us to use, equals 59.55x minus 1211.51. So that is a representation of the line that I drew on that previous screen. Now we're going to use that function to find out how many runs we could expect a team to score if their on-base percentage is 34.6. And so x represented their on-base percentage, so I'm replacing x with 34.6 and finding my answer of 848.92. Now, of course, it's a story problem, so I would write my sentence. We predict that a team whose on-base percentage is 34.6% will score 849 runs. So I just rounded that to the nearest whole number. So again, that's the use of linear modeling. I'm going to go back to this screen for a moment. Remember that that prediction is based on that blue line that I drew, and that blue line that I drew, I used 2 points that were on that line. So when you're doing this yourself, make sure that you're not just choosing any 2 points on the table, but that you're actually finding 2 points that are on your line and then using those to make your equation or your prediction model, and then use that to actually do your predictions.